for Good, the leading United Nations platform on artificial intelligence. Organized by the International Telecommunication Union, the United Nations Agency for Digital Technologies, in partnership with over 50 UN agencies, and co-convened with Switzerland. The mission of AI for Good is to unlock AI's potential to serve humanity. As a multi-stakeholder platform, AI for Good advances solutions, standards, and skills. In today's AI for Good event, we are counting on you to use the live video wall feature to ask questions and post comments to help create an engaging session. Boost your AI skills and elevate your career with the AI for Good Discovery Badge. Receive verified digital credentials that recognize your engagement in cutting-edge sessions, exploring how AI is being used to tackle global challenges. To see if a session is eligible, look for the blue badge banner on the right side of the video interface that activates at the end of each live session. Share your badge on LinkedIn and across your professional profiles, and check the AI for Good events webpage for upcoming eligible online sessions. Discovery Badge sessions are part of the AI Skills Coalition, ITU's global initiative to strengthen credible AI learning pathways and expand access to high-quality, trustworthy AI knowledge worldwide. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished facilitators and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Good time of the day for you all. Welcome to this AI for Good series webinar today, featuring some of the work that we are doing under the ITU, WHO, and WIPO Global Initiative on AI for Health. So we're going to be here focusing on the work of the Working Group on Data and the plans for it, featuring two key elements of the work. The open code infrastructure, OCI, and then the developments with Croissant and the concept of data marketplace. So I am Simão Campos. I work with the ITU Secretariat, and I'm helping lead the Secretariat of the Global Initiative. Now, I would like to introduce my other co-moderator, Eva Keller, who will also give you a few words. Eva, please.
Hello, everyone, and welcome to today's webinar. And thank you all for joining us. I'm Eva Keller, and I work as a digital health standards and AI consultant at ITU. And before we begin, just a quick note. So if you have any questions during the session, please feel free to drop them in the chat, and there will be a Q&A after the session where we will address them. So now it's my pleasure to introduce our speakers. So first we got Marc Lecoutre, who leads the open code infrastructure of the Global Initiative. And he has practiced AI and machine learning for over 15 years and founded several companies in this field. Next, there is Luis Zoala. He is the co-founder and chief AI officer at Brickroad and is a final year PhD research scientist at the Department of Artificial Intelligence at Fraunhofer HHI in Berlin, Germany. And finally, there's Raisa Youssef, who is a PhD student in the lab of Sebastian Lobentanzer at Helmholtz Munich, and her current research explores the use of agentic AI in clinical trials and the broader landscape of health information systems. So with that, let's get started. I will share my screen with the slides. And I'm happy to hand over to Simão.
Yeah, thank you, Eva. So I'd like to just start with a brief overview of the Global Initiative. So if you can go to the next slide, Eva. Yes. Oh, yeah, thank you. So that's a joint initiative that ITU, WHO, and WIPO created to harness the AI use for the benefit of health. Implementing a global coordination for standards governance, knowledge sharing and implementation support. And it builds on the work of the ITU and WHO focus group on AI for health that run from 2018 until 2023. Next slide, please. So those the deliverables of the focus group developed in different areas. They focus basically on the needs for benchmarking testing and trying to address the more direct public of people trying to develop solutions on AI for health. And then coming from the different angles of ethics, regulatory guidance, data quality, data issues, software control, and so on, and trying to apply that to a number of use cases. So that work was important. However, it was not sufficient to address the needs for several other stakeholders, in particular more governmental and/or policy definition people. So in order to broaden those interests, we created the Global Initiative based on three strategic pillars. So the first pillar is the enable pillar, which is kind of a continuation of the most of the work that was done under the Global Initiative, of the focus group, to provide the guidance. And then trying to expand that from this developer focus to a broader focus, not only the developers, but also these more institutional users, policy developers, and so on. And then in order to make sure that this could expand, we are broadening this concept of the facilitating function in order to convening stakeholders and identifying enabling mechanisms. So the Open Code Initiative, as it was called in the focus groups times and now being called Open Code Infrastructure, is a running code version of the framework that was developed under the focus group. And Marco, we're going to speak a little bit more about that. But then we also wanted to have the solutions implemented adopting countries. So this is also a focus of the Global Initiative to identify ways to implement and have it applied on the ground so that you can have a direction towards sustainability. Next one, please. So in terms of the governance, we have a steering committee that is a high-level representatives from the three organizations. And we have a joint secretariat from the ITU, WHO, and WIPO that we kind of manage the organizations. And then we are structuring working groups, topic groups, and facilitation groups that would deal with the technical matters. So, and then, of course, we need the support of partners and donors that would come to help support and, in a way, enable finance the activities. Today, we're going to be focusing on the work of the working group data that I mentioned, and we're going to see more details on some of its activities. So it is one of the working groups. But to see to have an idea, next slide, please. Of the yes, this is about the different types of groups, working groups, topic groups, and facilitation groups. Next one, Ivan. Yes, so the groups that we have established in terms of the working groups, we have one working on regulatory considerations, ethics and governance, data evaluation, and intellectual property and innovation. And then so these are horizontal breaching groups, so dealing with topics that cover many different application areas. And then we have the topic groups, which would be more focused on particular health use cases. So People familiar with the focus group see a resemblance between the structure, so we kept more or less the same. But the idea is that in the topic groups, they would be a little bit broader than what we had in focus groups times. So we have one that is already functioning on traditional medicine, and two others that are starting, and the one that is currently on hold, some others under discussion that I did not list here. Next one, please. In terms of the working group data, the scope and rationale for it is to address fragmentation and high transaction costs in health AI data usage. We are going to be working on developing a data and model exchange protocol to support discoverability and access. As I mentioned, it builds on the focus group benchmark experience, the various deliverables, and focus also on new features, in particular, the Croissant family of specifications. Next. And here are the objectives that you have currently defined for the group in terms of investigating dataset metadata standardization and basic matchmaking, searchable ontology-linked index of health datasets, secure transaction protocols, and federated testing environments and real-world pilots. Next. So this is what I wanted to bring in terms of the discussion. So now we're going to have a deep dive into the different work, and then I'll ask Mark to start the presentation. Thank you.
Thank you, Simão. Welcome to everyone. Happy to be here this afternoon. I'm going to introduce what the open code infrastructure actually is, an overview focusing on today's topic, the data catalog. So as an introduction, health AI is only as good as the data behind it. And today, finding suitable data set for training or benchmarking in the AI health sector is a fragmented process. If you're a researcher and you're looking for diabetic retinopathy images, for instance, for a diverse population, there's no single place to search. So this isn't just an inconvenience, but it has real consequences for health equity. So a data set from underrepresented population remain invisible, leading to AI system that works well for some and poorly for others. Next slide. So the OCEI builds shared open source infrastructure for health AI under the Global Initiative on AI for Health. So we have contributors from all the continents, engineers, doctors, regulators, and academics. Our platform covers the full life cycle of building and validating AI model. But today I would like to focus on the critical piece, which is the data catalog. Next slide, please. Thank you. So our platform covers the entire life cycle from data sourcing through evaluation. But today I want to zoom into the piece of data catalog. So it's powered by Croissant metadata that you will hear in much more detail after my speech. And it follows a federated model. So that means that the data stays where it is, and only the metadata is centralized for discovery. Next slide, please. So today, a typical health data is described in a README or paper supplement. But with Croissant, the same data set has a machine-readable descriptor that search engines can index, tools can validate, and platforms can ingest. The data becomes a product and not a mystery anymore. Next slide, please. To power our catalog, we adopted Croissant. Croissant is an open metadata standard from MLCommons. It's built on top of schema.org. And the same vocabulary is used by over 40 million datasets on the web. Croissant combines 4 layers into a single JSON LD file. And critically, It is already adopted by Kaggle, Hugging Face, and Google dataset search. So datasets described in Croissant are immediately discoverable across the ecosystem. Next slide. The working group BioCroissant extends the croissant with health and life science vocabulary. It adds 6 critical dimensions. So the biomedical ontologies, clinical context, the patient metadata, regulatory attributes, provenance, and cross-border comparison. So a chest X-ray dataset from Kenya and another one from Germany can now be described, compared, and discovered using the same terms. And this is essential for benchmarking. You cannot compare model performance if you cannot compare the data. Next slide. So in practice, a hospital describes their data sets using a croissant descriptor, and our platform ingests this, indexes it, and makes it searchable. A researcher looking for diabetic retinopathy fundus images from diverse population can search, filter, and compare without any data leaving its origin. The key principle here is data sovereignty. Next slide. On the left, data sources, hospital, research labs, clinical trial sites, and each in their own country with their own regulation. The data never leaves. What flows in is croissant metadata, a structured descriptor. On the right, customer search the catalog and discover relevant datasets. The architecture respects data sovereignty while enabling global discovery. And now I would like to hand over to Luis, who will take us deeper into the data multiplexer topic.
All right, wait, let me set a timer. I'm gonna do this right. I promised 10 minutes. I'm gonna be 10 minutes. All right, so nice to meet you guys. Thanks, Mark. I'm one of the other working group chairs and active in a bunch of places. Later, we go in full depth into the exciting stuff that's happening in BioCroissant. Raisa has a really nice in-depth presentation. The goal here is to give a bit of a 360 and treat it maybe as a little like history lesson on how we got here, what happened up till now, and what the kind of underlying assumptions and goals are behind some of the stuff that we are doing. Next slide, please. So I went a bit through my slide bank, and this is something I found from like, I think 2 years ago it was at AI for Good Summit in Geneva in person, where I think a bunch of us met to discuss some of the stuff that is now finally hitting the road. So we already had the croissant spec in place and started feeling out in different places how we can bring this more broadly into the health domain. Next slide, please. So the whole history for behind Croissant and the community is a bit too much to go into detail, but just to give you a bit of a snapshot, the seed started sometime in 2023 when a bunch of people across different domains, we met in a workshop at Asiloma, and the basic question was around access and connectedness, all the things that Mark described in the first part. And we already had some experience inside the focus group on how to navigate this, but what became clear is that we need a more deeper connected solution so that data formats can be shared across not just different entities organizationally, but also even different communities. Next slide. So if there's a couple of things I want to emphasize, or I hope that you can take away from this, is A, this little history lesson, 2, some of the like assumptions that we operate on behind some of these projects, and then 3, the kind of goals and current activities that are going on. And I hope that many of you feel invited to contribute. So this is happening within the ITU initiatives. This is happening within the Croissant working groups. Again, you will hear more about the bio extension and how to contribute there later on. So it's an open invitation to really help shape this space, and it's all open source. So yeah, let's go quickly into the assumptions so that you get a sense of where we're coming from and where we assume the future might go. Next slide, please. So I have this always in here. We can skip right to the next, so I can save some time here. I always take this little figure in my slides. It's from a very obscure paper that has nothing to do with datasets actually, but the TLDR is quite interesting. So what you're looking at the left is satellite imagery from cities in Europe, I think around 2010 or something like this. And what you see on the right is how it correlates with the road density from the Roman Empire. So as you might know, the Romans, they built streets all over the place. They also did a lot of bad stuff, obviously. So it's not the point here. The point is just that the lasting impact of the road networks that they built have compounding effects today. So economic activity, which usually a lot of environmental economists measure through this kind of nightlife activity. So they just basically look at how much light is there during the night and use that as a proxy, correlates a lot with the density of nodes of the Roman road network. And I think that's really something that drives us also here when it comes to data. We really want to make data flow and build a public good that compounds over time and for generations to come. Next slide, please. Another important aspect, and I think this comes more to the forefront also now in what it's called this agentic era, whatever you want to call it, right? Like systems are being deployed into production. People use it in their day jobs. It's not just anymore like a big research community. It's a product, it's a technology that is in everyday life. And one of the things that I find quite interesting is when it comes to data access, there's always a moving frontier around information, right? Like think about a doctor that needs to treat a patient. They need up-to-date measurements. They cannot just operate on past measurements. They need the new measurements from that patient, right? And this kind of story plays out in all types of verticals. So what I mean here with the information frontier and this ominous MOMSI galaxy, which to date, or I think at least 2 months right now, the point being there is always this frontier of information that exists at any given moment in time. And what we want to enable the infrastructure to do is to penetrate that and pipe data from that frontier right to the endpoint where it's needed. Next slide, please. Hello, hello, hello. Can you hear me? Next slide, please. Or is it just lagging on my...
We have the assumptions is lagging on the screen.
Okay, I still see my nice galaxy. So let me go. Do you see some long tail distribution?
Yeah.
All right. So I'm just gonna go off whatever I have here and then trust whatever you guys see on screen is the same thing. The third piece is that what we already see in production systems, the task and types of performance profiles where we need to pipe data into has a very long tail, right? And this applied to medicine, when we talk about precision medicine, this like vision is not really new. What this means for data access is that we, again, have to be able to have very high resolution and granular access to a specific type of data that is relevant for the context in place. So we have the assumption of compounding effects on network density. We operate on the assumption that this information frontier is constantly moving and the data system has to adapt to that. And we assume that real world value of these like public good data standards really rely on having high granularity and high resolution. So let's look a bit into where we want to go with this. Next slide, please. do you see some elephant and some car?
Yes.
All right. So the goal behind a lot of this standardization activity really, I think, is encapsulated in the left-hand graph that you see on the screen. So ML systems combined, right? There's many pieces to it. We are not dealing with everything. We are not dealing with like the compute hardware. We are dealing with a little brick that is the data. And what we want to contribute to the bigger picture is making sure that the transaction cost incurred across ML workloads in the stack from data get reduced more and more over time. And what this transposes to is more and more tasks become feasible, right? And you can imagine this as if you're a researcher or somebody working in a day job with AI systems, how annoying it sometimes is to access certain data sets. Now, that's exactly what I mean with transaction costs. So we want to make it as smooth and cheap in terms of time, but also in terms of hours like you spend on that to access data. Because what that means at the end of the day is that you can more tasks become feasible. And if you translate that to medicine, it means you can potentially explore new treatment avenues or new experiments that previously maybe were not economically viable. Now, there are challenges, and I think the biggest one is that you're basically building a car while you're driving it. It's with most technologies. So especially if you try to do something harmonizing or like a standard, it just means that you get caught up in a lot of kind of harmonization activities. All right. So let me quickly run through the last three things in terms of activities so that you get a bit of a sense what's currently going on, and then we can dive right into BioCroissant. Can you go to the croissant slide?
Okay.
Yes. Okay.
So some of the activities that we've been undertaking, I think, can be neatly transposed across like three axes. Croissant is the standardization on the data layer itself. Mark, I think, already outlined it. You have a link here to the repo. We will go into more detail about this in a minute. Next slide, please. Can you skip one more? Now, the other question relating to data exchange and the commodification of data is how do different entities transact on these with provenance proofs and the transactions being recorded. That's another big avenue of exploration at the moment. We also have a task group for that in Croissant called Croissant Task. And we presented some recent work on this at the last NeurIPS, where we basically analyzed how much volume of publicly traded data we can actually find on the web. And that's a very important problem, especially when we move into production systems, because you need a clear auditability on where some data came from, where the data is going to go, what the license and usage rights are. So that's something that we really want to tackle with the community as well. And the next slide, please. And the last one. The last bit where these two things then really come together is making sure that we put the transaction and the format on steroids. One of the challenges around Croissant at the moment is that for some production systems, it's still quite tedious. And when we talk about transaction cost, like slow to work with. So the other axis of optimization and performance is around this concept, what I call multiplexer. The idea being is that we really maximize network traffic and network routing, and that's another active axis of exploration. So I hope you have some sense now of what our kind of starting assumptions were, where this all comes from, where we are trying to go, and what the active areas for contribution are across the ITU, across MLCommons, and all the other great research groups and community that is active across the space. I think there is one more North Star slide, which this is the one that I basically just said, so we can skip this. And I will hand over to Raisa to go and give us a nice walkthrough on BioCroissant and where the journey is going for healthcare.
Yeah, thanks, Lewis. Hi, everyone. Thank you for joining. You can go to the next slide, Aoife. I'm going to talk a bit more on what Croissant looks like. What has been done? What does it look like if we use Croissant? And not get too technical, but just show what has been done and where can we still improve. So next slide, please. So when we're looking at traditional software, for example, the quality of that software relies on clean and well-structured code. And in a similar way, AI systems rely on high quality and well-described data. Now, in many technical domains, and such as language and vision modeling or imaging, datasets are already described in such a way that machines can easily find them, load, and use them automatically. But in healthcare, that is not usually the case. So we often have to deal with data that is siloed across institutions, countries, and systems, and this data is often in completely different formats. So as a researcher or an engineer, instead of building something for a task and trying to answer a question, you spend a lot of time just looking for data, understanding that data, and then manually preparing it. So the pre-processing time and setting up takes forever, and this becomes a major bottleneck. And that is exactly where Croissant comes in. So Croissant aims to make datasets web compatible. Oh, you can stay on the previous slide. Croissant makes datasets web compatible and machine readable without changing the underlying data itself. So it kind of builds on top and provides a standardized way to describe everything a researcher or an AI system would need to know about a data set so it can be used efficiently for downstream tasks. So to draw back on like the software code analogy, Croissant acts like the documentation and interface layer. So if you ever have worked with a Python package or an R package, a well-defined package will tell you how to use it, what functionalities they are, how to call on them, how to use them. And Croissant does that, but for data sets. And this is great if you have an idea and you want to build something and you don't want to spend too much time looking for preparing data. But it's also great for reproducibility if you want to test somebody else's experiments, and you can just quickly set everything up and see if you can reproduce the results and build upon them. Next slide, please. So how does Croissant work internally? We have a couple of layers, hence the name Croissant. First, we have the metadata layer, which just describes the data set at a high level. So who created it, where did it come from, what licensing, and some other general information. The structural layer is more technical. This defines how the data is organized, what fields exist, what data types exist, and how the raw data maps to something that's more structured, like tables or graphs. Third, the resource layer. This simply describes where the data lives. So this could be files, URLs, or external storage systems, and basically points to where you can find the data or where that data is being stored. And finally, the semantics layer describes how the data is intended to be used. So for training tasks, what the labels look like, or if there are any evaluation setups. All of this is defined in a simple JSON LD format, which makes it machine readable and easy to integrate across tools. Croissant also has a lot of tooling around creating and interpreting these files, which is continuously being worked on. But these are like the main 4 layers, and I would keep this in mind because we will come back to these 4 layers in a second. But now we could go to the next slide, where I can just tell you or give you a brief idea of how you can use Croissant. So it's quite simple. You basically install the Python package MLCommons and essentially load a Croissant file directly into your project. So what's really nice is that there are already many existing Croissant descriptors available for datasets, so you don't always have to start from scratch. So for example, here on the slide, we have the Cancer Genome Atlas multimodal dataset on the left. This is just a collection of clinical data, pathology reports, molecular data, and radiology images for cancer patients. And this dataset is great for multimodal machine learning for oncology, so it's huge and it has many different things. Now, this dataset is available on Hugging Face, which is a platform which is very widely used, where people can find different models and datasets, and basically works as a registry. And if we look, we can see a little Croissant button there, which means that this dataset has a Croissant descriptor file, allowing for quick and seamless integration into any downstream task. Mark already mentioned before, Croissant is already adopted across a wide range of repositories like Hugging Face, Kaggle, and Google Datasets. So these are registries where really a lot of people look to find data that they can use for their tasks. So now that you have your Croissant file, we look at the code bit. It's not a lot of code, so it's not too technical, but you can basically point to or load your Croissant file and inspect the metadata to see, is it actually what you need? And once that's done, you can basically just load it in your machine learning workflow, for example, and start building and working with the data. So instead of manually figuring out formats, schemas, and file structures, that information is already there in a standardized way. And this works in many domains already, such as language and vision modeling. But as mentioned earlier, healthcare introduces some additional challenges. Next slide, please. So this is where the BioCroissant working group comes in. The goal is to bring Croissant into the healthcare domain and address what's currently missing. So for example, this is just one example in the European healthcare data space. There is already a standard called Health DCAT, which aims to describe and catalog data sets. Now, 2 slides ago, we had the 4 different Croissant layers with the 4 different colors. So this European DCAT standard only covers the metadata and partly the resource layers. So really, it's great for discoverability and finding data sets. And you would think that this standard sounds very similar to what Croissant already does. But the difference is that DCAT focuses on high-level metadata and dataset discovery, helping you find datasets, but what it does not provide is the detail needed to actually use the data. So that's where Croissant would complement this and add the structure and semantics layers, which describe what is actually inside the dataset and how it can be used for machine learning tasks. So kind of complementing this. This is just one example. I mean, if you look at the health space across different countries, different institutions, everybody deals with things a little differently. And I think Croissant would be really great to seamlessly integrate the technical and domain expertise. Next slide, please. So the goal is to bridge 3 different worlds together with one shared data language. In the center, we would have Croissant and Croissant-based tools acting as a translational layer. On one side, we would have the data world, so people who are managing repositories and building data pipelines. On the other side, we would have the healthcare world, where we have practitioners interpreting data through the clinical context and standardizing this data using medical ontologies. And finally, we would have the AI world, where data sets are used to train models, benchmark performance, and validate results. Right now, each of these communities works in very different ways with different tools and expectations. What Croissant would enable is a kind of smart metadata wrapping, where data sets can be described in a consistent, machine-readable way across all of these domains. So this means the complexity, things that concern the structure, provenance, licensing, and semantics, is handled by the tooling rather than by each individual user. So instead of everybody having to learn each other's systems, experts can stay in their own domain while being able to collaborate effectively. So in short, Croissant acts as a common language that allows these 3 communities to work together without struggling too much in terms of understanding each other. Next slide, please. So how does this connect to the AI for Health initiative? Well, it kind of is a 2-way street. AI for Health would provide real-world requirements and use cases that would help shape Croissant. Instead of designing a standard in isolation, we would get continuous feedback from actual practitioners, so clinicians, researchers, and engineers. This feedback loop allows Croissant to evolve in ways that are both practical and relevant. At the same time, improvements made through these real-world applications don't just benefit the healthcare domain. Croissant is domain agnostic, and any improvements would benefit the broader AI ecosystem. So it's a 2-way relationship. We have real-world needs that improve the standard, and then the improved standard benefits many domains. Next slide, please. So finally, how can you get involved? Well, there are many ways to contribute depending on your background. In the middle, there is a QR code which would take you to the Croissant main webpage where you can sign up for the mailing list. We have weekly meetings. I think they're every Monday, if I remember correctly, and it's just a great way to join and get involved and talk to people. If you're somebody who works with data providers, you can help the community and join describing data sets and improve discoverability and reuse. If you're more on the developmental side of things, you can contribute to tooling or integrate Croissant into platforms like what has already been done with Hugging Face and Kaggle and help expand the ecosystem. If you're not on the technical side of things, like I said, if you're a researcher or a clinician, you can bring real-world use cases and feedback into the working group, which is essential to shaping the standard. And if you're involved in more on the policy-making side of things, you can engage by helping align the standard and promote the adoption of this standard. And so the idea is that we build a collaborative ecosystem around better data standards for AI. I think the more people, the more perspectives, the more ideas, all that will really shape into something that is agile and works great across many domains. So yeah, scan the QR code, join the mailing list, get in contact, get in touch. Yeah, I'm looking forward to seeing many of you join the working group. Thanks, Eva.
Yeah, thank you, Mark, Luis, and Raisa for the overview. I guess Eva might have some questions to be asked. Do you have any questions coming from the floor, or should we prompt our own?
So because I was sharing the slides, I hope that everyone who wants to join and took a screenshot of the QR code already scanned the QR code, because I will stop sharing the presentation. And then I'm not quite sure whether there are questions in the chat already. So
maybe I could.
Yeah, so there are no questions. Yeah, so first of all, thank you everyone for the insightful presentations. We'll have roughly 15 minutes for the Q&A. So please feel free to post them in the chat but I'm happy to start with first question. So we've already heard from Raisa how to participate, but then also for the remaining speakers, would you have any concrete ways for participants to contribute to your work?
Thank you. Yeah, maybe I can start. So, as mentioned, I'm leading the open code infrastructure for the Global Initiative on AI for Health. And we're always looking for contributions from all around the world. We are looking for developers, regulators, data experts. I mean, if you have any expertise in the domains that we mentioned, should it be data or AI, machine learning, and so forth, federated learning, there's a lot of topics. You can check out the GitHub repository on focus group AI for Health. There's all the documentation available there as well, and all the topics on which we are currently working on.
I think I'm trying to parse through. I think Raisa gave a really nice overview. So in terms of also what the, let's say, areas of contribution are, concretely, maybe. So one thing we are currently dealing with a lot is tooling. So I think the spec evolves. So if you're interested in this kind of stuff, there's always opportunity to contribute, and we also have some, ideation at the moment through the global initiative to see how we can support such standardization through more formal channels. So if you're interested in spec development and standardization, I think that's in ARC, but we also see a lot of search of just people working on tooling. I think there's I think 3 projects going on. There's the Croissant Maker by Tom Pollard's group at MIT, which also is in the healthcare space, by the way. So it's a small world. I think they're also part of Raisa's and Stefan's group at BioCroissant. So that's something where, for example, they just want to be able to quickly create a croissant file from command line, right? And what this means in terms of adoption, and I was talking about this whole compounding bit, it's this when the gears start moving, because if it's easy for people to use, then it can bring the utility on the road, and then we help with adoption. So it's a feedback loop. And there's others, Croissant Minor. There's also a project called Eclair. You see the theme. It's French pastries all the way through on an MCP server that is already working. There's also a live instance that allows you to do croissant creation, validation through whatever MCP endpoint you're at. So I think that's another big one. Tooling to make to make the adoption and the use good in whatever local context people need it. And I think BioCroissant will surface more of these requirements in the healthcare space in particular. And then I think there's also a broader theme of just adoption. So if I think Luca Foschini from Sage Bionetworks, they are running one of the bigger healthcare, I think, aggregator portals in the US. That's a place, I think, things like this, they are considering adopting Croissant for their data. So if you're running a repository, or even if it's small just for research and you want some support or way to connect it, I think that's a good through line to collaborate, because it helps the harmonization of the space if you adopt it, and there is a group of volunteers scattered across that is happy to support. So I would say spec development, tooling, and adoption, no matter how small. If you feel like you identify with any of these, there is reach out to Raisa. I think she can route you to the right place, or Mark, or me. Yeah.
Okay, thank you, Lewis and Risa and Mark. Yeah, so lots of opportunities to contribute. And we actually got a bunch of questions now. Two are actually quite related, so I might actually ask them together. So one is from Gaurav Sharma. So, from Nursey Ruston. Are you using data standards like HL7, SOMIT-CT? And Princey Bhavna, he's asking, how does this work with known data standards like FHIR? What are the considerations?
Who wants to go? I can start while people collect their thoughts. So the short TLDR is yes. I think that's actually one of the nice feats, especially for healthcare, that Raisa's group started with, because they didn't just march and said, we need this and that and this and that. They actually looked at a lot of the existing landscape, identified some of the gaps, and also the mapping. So and Raisa, please correct me if I have this wrong. This is a silent post from Stefan, but maybe there's some details to that. But one of the goals, as I understand it at the moment, is around making these existing formats compatible. So rather than having, there's this meme around, we have 14 standards, let's create a standard to unify them, and then at the end of the process we just have 15 standards and there is nothing really one. So I think the approach that the group is taking is quite smart here, is trying to map and then have compatibility with existing formats. So that's the general direction, but it's also early in the game. So if you have some cool ideas in that direction, I'm sure this is a nice way to contribute.
Okay, thank you, Lewis. So actually someone is asking whether it would be possible to share the link for the QR code. My apologies, it was actually quite short, the time that we showed it. So if Raisa, maybe you have the link,
I can do that.
That would be awesome if you could post that in the chat. So next question, the one by Gaurav Sharma. So the relationship with regards to grassroots health applications, could you provide a rough example, say in primary healthcare?
Sorry, could you repeat the question again? I was just getting the link for the working group.
Oh yeah, sorry, my apologies. So Gaurav Sharma is asking what's the relationship with regards to grassroots health applications and whether you could provide a rough example, for example, in primary healthcare.
So I don't have a concrete example for primary healthcare at the moment. There is one thing where we had this open targets project happening. So the idea was, it's more perhaps again a bit too technical, but the idea was that we have this drug discovery or target discovery platform. And to basically automate knowledge management, they use Croissant files to automatically build a combination of these different data sets. And basically what they did was create knowledge graph adapters that were built from this metadata. So then you could bring together multiple data sets, create this huge knowledge graph out of it, and use this for like targeted like drug discovery and open targets. I don't know if maybe Lewis or Mark have any other
Yeah, to me, so I would say generally we are not as close to the downstream use of the data, apart from people being able to consume it. And I think at the moment closer to the supply side, because a lot of the effort around the standard is to be able to index and make the data available. But I think one of the more immediate use cases where, you were asking about like grassroots, smaller applications is, I think, for example, is the NeurIPS datasets and benchmark track that has adopted the format last year, which basically means any research paper developing a novel idea, novel algorithm, or it could be an app, or or basis for an app, wraps their data artifact in Croissant to make it possible to have that standardization, but then also downstream for others to work on the data artifact in context of the algorithm and the other code that they are providing. And the piece I mentioned on Croissant task is basically the glue that we are trying to set up here. You can think of it basically as combining a description and some executable form of the algorithm or code that then is doing something to the data with the data itself. And that is work in progress. So I think in terms of existing adoption, NeurIPS DB track is a nice example. If you check like last year proceedings, I think there's basically 500 bespoke applications of some type of downstream vertical with Croissant baked in. And you can browse that on the NeurIPS DB open review. And then, I think it's an evolving landscape. So it's maybe a good idea to build that index, actually, now that I'm talking about it. Like we should have a little gallery, little milestone gallery, like all the cool things people are doing with it. So maybe that's something to take away here.
All right, thank you, Lewis and Risa. So we have 4 more questions and only 7 minutes left, so maybe we can hurry up a little bit. So one question is for Lewis. So could you elaborate on the adapter strategy you mentioned towards the end of your section?
Yeah, so I try to keep it short, knowing my tendency to ramble and monologue. The idea basically is also not so crazy or groundbreaking. Idea is basically, I think we started work on this in a world where the LLM substrate wasn't quite there yet. Now we are in a place where you can quite easily transform data on the spot with an LLM. Like an LLM doesn't have really problems to, for example, create a Croissant file. Before, it wasn't, like 2-3 years ago even, it was still more challenging. So what the adapter basically means is that we can have a lot of in-place conversions rather than having deterministic mappers between formats. So what this means downstream is we still need specifications, but whatever somebody is doing, we can allow for more freedom in terms of transforming to the export format that the other endpoint uses for ingestion on the spot. And I think that's an interesting primitive just in terms of how we design these systems. So I shut up.
Thanks, Lewis. And next question, can you elaborate on how does this spec help with federated approaches to data access? Maybe for the whole group.
Mark, you want to? I don't want to monopolize this Q&A race.
Yeah, I mean, quickly. I mean, what I mentioned today is the catalog, which is the core of it, because we need to know where the data lies. The whole thing is to have data stay where they belong to and in their regulatory environment. There's a lot of challenges with data privacy regulation all around the world. So the idea is really to bring whatever processing needs to be done on those data to the data, and then bring back only the results, and then federate all these results, should it be for training, for benchmarking, and all the activities that we have in our OCI. Obviously, it's a bit more complex because there's also agreements that need to be to be signed, and the platform is actually dealing with all those challenges here. So it's really the idea to have data remain where they belong to, bring the compute to the data, and then bring back whatever parameters or output has been computed without any PII or data leakage.
Okay, thank you, Mark. So if nobody else wants to add something, let's go forward with the next question. So the next one is, could you please comment on what kind of biological ontologies is BioCroissant built on to work with different healthcare data and modalities?
So I think if you want to do a little, so again, not going into a complete tangent, maybe let's link the current working doc for the BioCroissant group, and there you get a really nice breakdown on the different seed formats and ontologies that are being used to feed and map into the BioCroissant standard. I can quickly look for this, and then you can have a nice compact overview. And if you know of others that you think should be considered, a good place is also the GitHub repo. I think Stefan monitors that for issues. So if you have something small that you think could be added, that would be a good place to do that. But I can quickly get that link for you, and then you can go into the rabbit hole to your heart's content.
Okay, great. So I hope you don't mind if we go forward, Lewis, with the next question. So the next one is, what do you think is the next step in terms of adoption and implementation within the developers community, and what would be your vision in the next 6 months to see this in action?
Raisa, share your vision, please, for BioCroissant. I will add on at the end.
I mean, I think the idea is just to have this as widespread as possible, and we get so many people together. I think the way, even just within the healthcare space, how people work so differently, and how they store their data, and how they work, how they set up their workflows, it's also different. And just bringing everybody together, because when you talk to people, everybody wants to collaborate, and there is always this enthusiasm to work together. But then that stops very quickly because you're faced with hurdles by just sharing and resources with each other and getting together. And I think if we just break down these hurdles and finally focus on actually building stuff and working on stuff, I think that would be so great, just to speed things up and actually answer the questions that everybody's been asking and wants to work on.
Okay, and one very, very last question and short question. Did you ever consider that Health AI could develop their own algorithm for data acquisition, storage, access, use, just as an experiment?
I think that's,
and then we'll close the session.
I think that's the direction with the Liquid API bit. I mean, I think there's limits also around, just in production, you need certain robustness guarantees. So I'm curious to see where this actually lands. But I think the direction is that's an interesting direction, let's put it that way. And there's a lot of potential in exploring that. I suspect it will be some hybrid where, people worry about reliability, and so they bake in a few hard verification checks, but then let a lot of the other stuff be liquid around it. Yeah, join the BioCroissant to find out where the journey is going.
Okay, great. Thanks, Louis. There's one question left, but I'm afraid we don't have enough time for that. But please feel free to reach out to the group, and also subscribe to the focus group mailing list, which is still active, by the way, from ITU. And thank you very much for your attention. And yeah, very looking forward to the future work.
And thanks for hosting, Eva, Paulina, and Sema.
Thank you very much.
Thank you.
Thank
you. Guys. Bye-bye.
Thank you.
Thank you for participating in today's AI for Good session. We hope you've learnt something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for good.